Okay, g'day. This is Gerard here from Point Zero Engineering. This is going to be a quick tutorial on dynamic simulations in Autodesk Inventor. Before we get started, there's a key philosophy here is that in the assembly environment, you start with a bunch of floating parts and you add constraints to join them together, just using your joints and constraints tools. In the dynamic simulation environment, you work opposite. You start with a bunch of grounded parts, and using the joints, you're going to grant them degrees of freedom. So first things first, we're going to go into simulation settings, and we're going to turn off automatically convert constraints to center joints. This creates more problems than it solves, is what I found anyway. If your model was fully constrained in the assembly, then you can use the convert constraints tool. It will give you you'll pick two parts and it'll give you a selection or a couple of options for the type of constraint that suits, rather the type of joint that suits the constraints that were in your assembly. In my case, my models were fully floating in the assembly. They were not constrained. I think they were grounded, but that's okay. So I'm going to start by ungrounding them here. I'm going to pick the ones that I want ungrounded. So they're now floating, and my bottom piece here is grounded. So that's fine. So I'm going to start by selecting joints. Now in my case, I want a revolution joint. There's some information here about the different types of joints. I think if you click on them, you can select them up here. So in my case, I want revolution joints. I'm going to do the three main pins. And I'm going to start by picking the z-axis. The origin is important. It's a common point between the two components. So when I select my second component in a second, it will position them so that they have the same origin point. Now the x-axis is not required, but it's helpful. If you have multiple joints, you're going to want to see that they have a common alignment, so that when we get to our results later on, we don't have to worry about negative inversions and offsets and things like that. For this situation here, I'm actually going to leave that off because it's a simple enough assembly. Now I'm going to select my second component. I'm going to select in there. I'm going to select the origin, which is going to be the same circle edge, and then click apply. Now, quick note, my assembly has no gaps in between my joints. In a typical assembly, it would be pretty common to have gaps in there for assembly tolerances. That won't work. It'll try and shift one of those positions, one of those components to align. Now, okay, I created my first one. I'm going to create my second up here. One, select the origin, select the z-axis for the second component, select the origin for the second component, and hit OK. So you can see here we've got a triad on these joints. Now, if we go into our edit, the blue one is our first component, the green one is our second component. And what we have is we have one arrowhead for the x-axis, two arrowheads for the y, and then three arrowheads for the z. Now I'm going to go on and continue to add my third revolution joint down here. One edge, then my second component, and my second component origin. Okay, and now my last one is the cylinder. I'm going to add a cylindrical constraint here. Select my first component. Now this time I'm going to select my origin as the center of my eye, and I'll explain that a little bit further in a second. Second component is the cylinder casing, and my origin is going to be the eye. So what happens here is when we show the initial conditions in a moment, it'll set with an initial condition that is the distance between those 2 points. I'll click OK. Now it says my mechanism is over constrained by 2 degrees. That's okay. I can allow it if the 2 degrees are in degrees of freedom that we're not interested in. So in the moment, we're interested in more like a hinge mechanism. So if our over-constrained degrees of freedoms are in the X translation, that's fine. So what I can do just to demonstrate that is in this joint here. I think our constraints are over-constraining is coming from the cylinder being over-constrained in the X translation direction. So I'm going to change this one. I'm going to delete it. I'm going to add in a cylindrical constraint. So the difference between a cylindrical and a revolution is 1 translation degree of freedom. So I'm going to select my first surface, my second, first origin, my second surface, and my second origin. Hit OK, and I've now only got 1 degree of freedom warning. I'm not happy enough with that, so I'm going to click Don't Show This again. Okay, by now we should be able to move this, and we should get something sensible. So what we're doing here is just doing a dynamic motion, which allows us to click and drag. But we're getting sensible movement here, so I'm happy enough with that. Now we're going to add a trace. So up the top here, I've got a point that we want to inspect. So I'm going to add a trace up here. I'm going to select trajectory. Our reference is grounded, that's fine. And I'm going to add a force. Now I'm going to use vector components for my force. The location is there. My direction and load is negative 20,000, so that's about 2 tons. And I think we're good to go. So we also want to add a gravity. So I'm going to define my gravity over here. Vector components, negative 9810. And there's our gravity. Okay. Now we're going to go in, we're going to try and drive this. So we want to do a simulation study. So we're going to drive our cylindrical force. We're going to go properties. Now, a quick guide on this dialog. So first we've got our general tab here. We can do a few things. We can suppress and lock the freedom. And then across the top here, we have the degrees of freedom that we have available. So DOF2 and DOF1. Our T is for translation. Our R is for rotation. We're interested in translation. Now, across the top here, we've got edit initial conditions, edit joint force, and edit imposed motion. We are going to start by setting some initial conditions. And I'm going to set this to be negative 1650. I think, there we go. And that's positioned that there. If we had friction that we wanted to consider, we can set up some friction in the joints. For this case here, I'm not too worried. I think we can also set a joint force here, like a torque. On our rotation tab, we could enable joint torque. There we go. So translation, I'm going to go to edit impose motion. I'm going to enable impose motion, turn on position, and then I'm going to click on our little graph editor here. So first things first, this is our graph. We've got 2 points. We've got a start and an end point, and we've got some control down here. What I'm going to do is I'm going to double click here and here. I'm going to add in 2 more points. So remember that our initial start point was negative 1650 millimeters. And I'm going to set that at a time of 2. And then our end point, I want to set that to be negative direction in my case. I'm going to go to 2500. Okay, now the second group, I'm clicking between these areas here to get these colored bands. Second place is going to be, second endpoint rather, is going to be 3 seconds, and it's also going to be 2500. So I'm just pausing in that position for 1 second, and now I'm going to return. Start endpoint is there, and I'm going to set my endpoint here to be 1650 again. So that gives us that profile. Now we can also set ramps in between our positions. I'm not sure why it's not updated. This should update, give us a ramp profile. Not sure why it's not working there. We'll come back to that one later. Okay, so now I have everything that I need. I'm going to go into Simulation Player, play that out, and we can see it moving. It hasn't moved as far as I want, so I'm going to click this button here to go back and edit. And I'm going to change my properties, edit that graph, and set my end distance here to, let's go 2800. And I'm going to move my end point here back to 1650. Negative 1650. Try again. We can go a little bit further still. Negative 3 meters. So this is a stroke of our cylinder. So we're traveling from 1650 to 3 meters. Okay. Hit OK and play. And that's good enough. We could go further if we want, but that'll do for now. So now that we have our simulation, I'm going to go up to our output graph here. Expand our assembly, expand our standard joints. Now we're interested in the cylinder. We want positions. So that is our rotation, I think. It should be, I don't know what's happening here. Simulation settings, sorry. Simulation player, we haven't changed this. We need to set this to 5 seconds to match our return profile. Okay, and now we've overextended. So I'm going to go back to shrink this down a little bit. Negative 2200, say. Our endpoint here should be negative 1650 again. There we go. All right, let's try that quickly. Okay, we can go further than that. Let's go 2500. Perfect, that'll know. Okay, close. I'll show our output graph again. Here we can see our position, extends, pauses, and then retracts. That's great. So the next one we probably are interested in is our force. So this is the sum of our forces in our X, Y, and Z directions. If we are interested in a singular direction, we can click on the direction that we're interested in. And in this case, it's probably the Z. So we can do a search max, and it'll immediately move our cursor here along, and in the background, we can double click on different areas and it will show us, update the model in the background to suit. So searching the maximum force here is 112 kilonewtons. And our position here, we can sort of see how that pathway is moving. Now, if you wanted to do a little bit more accurate model, more of a representative of the real world, you might want to change your driving force on the cylindrical and change your imposed motion. You'd have to enable a joint force, I think. And then that sort of represents driving a hydraulic cylinder using hydraulic pressure, and you would limit the motion on your pivot joint down here so that it can only extend to a certain range. Anyway, I hope that helps. That's enough for now. Until next time, all the best.